Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy and today we're going to discuss how dampers affect diffuser sound performance. Lots of diffusers have dampers mounted to the inlet, but have you ever thought about how that affects the sound of the diffuser? Let's draw a diffuser with a damper on it. So here is our back pan. So we're looking kind of from the top, and then we'll draw a little damper in here. So this damper is essentially wide open. Just putting the damper on the diffuser adds a pressure drop to the diffuser, even if it's wide open. And if you have the damper here, you probably intend to close it off at least a little bit. So let's look at how the sound changes. You can determine the increase in sound by calculating the effect of the damper on total pressure. Basically, you're looking at the ratio of total pressure with the damper as you close it off to total pressure without a damper at all. As you close the damper, the total pressure goes up and the sound does as well. If the ratio of total pressure is 100, the sound would be the same. If it's 150, you would add 5 NC to catalog data. If it's 200, you would add 8 NC, and at 400%, you would add 16 NC. Okay, so let's scoot this up out of the way for a minute. Let's say you have a round damper in the neck of an 8-inch TMS diffuser. At 200 CFM, the catalog says the total pressure is 0.036 inches and it has NC 11. So now if you close the damper to 50% at that same 200 CFM, let's look what happens to the pressures. We'll start with the velocity equals CFM divided by the area. Our CFM is 200. Our area is pi r squared divided by 2 because it's 50%, divided by 144 because we need to put those in feet. So this section's together here. You do the math and you come up with 1146 feet per minute. With that, we can calculate the velocity pressure, which is 1146 feet per minute divided by 4005, and take that and square it, and you come up with 0.0820. So our velocity pressure with the damper closed off halfway is 0.0820 inches. Now we really need the ratio of total pressures, but let's do it this way. We know that the total pressure is the velocity pressure, 0.0820, plus the static pressure, divided by the total pressure from before, 0.036, and that has to come out to something greater than 2.28 or 228%. Because 0.0820 divided by 0.036 is 2.28. So now let's go up to our chart here that we had before, and you can see 228% or something greater than that, maybe we'll call it 300 if you were to add in an actual static pressure, puts you somewhere between 8 and 16 NC. So now we had NC 11, and we're going to add to that about 12 NC, and that gives us NC 23. So what started out as an NC 11 diffuser is an NC 23 diffuser when you close the damper halfway. So I know this example might be kind of extreme. You wouldn't necessarily close it halfway and still try to maintain your CFM. But because of the square relationship between velocity and velocity pressure, even closing the damper by 25% will result in a 200% increase in velocity pressure and can add 6 to 7 NC. So even wide open, the damper will add pressure, and this will add 3 to 5 NC to your diffuser performance. And it can also go up pretty quickly to 8 or 10 NC as you close off your damper. So what should you do about this? The best solution is to put your balancing dampers upstream in the branch takeoffs. So now you know what happens when you add an inlet damper to a diffuser. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.